Okay, welcome to video 8.3 here. We're going to be talking about exam radical questions. So just so you kind of have an idea of what they've asked in the previous exams relating to radicals and really what I want you to know about radicals. So we talked about already rational numbers versus irrational numbers. So this is really a review concept. And we talked about it in the first day of this unit. Rational numbers, remember, are numbers that can be written as a fraction. So I wrote this as any number that can be written as a fraction. We can use our calculator to check. Remember that repeating decimals and terminating decimals can be written as a fraction. Irrational numbers, on the other hand, cannot be written as a fraction. So the numbers are non-repeating and non-terminating. Again, we can check in our calculator to see if the number can be written as a fraction or not. And we do that by using math_frac. So the typical questions that you've kind of seen and that you should be able to answer are things like this. Miss Fox asked her class, is the sum of 4.2 and radical 2 rational or irrational? Patrick answered that the sum would be irrational. Now we need to state whether Patrick is correct or incorrect and justify our reasoning. So when we talk about the sum, well, we can do this in our calculator just to be sure. We can put 4.2 and we can add radical 2, and we end up getting 5.614213562. So I just wrote that down, and now that I know that it is a long decimal, it doesn't repeat and it doesn't terminate, and we can be sure by checking math_frac to see if we get a fraction or if it just repeats that decimal back to us. Since it does not put it as a fraction, this is irrational. So let's see, what did Patrick say? Patrick said that the sum would be irrational. So is he correct or incorrect? And we're going to say that Patrick is correct. So all I really needed here was that Patrick is correct, but I just kind of added so that you understand why he's correct. The sum is irrational because it cannot be written as a fraction. We could also have said that it is a non-repeating, non-terminating decimal, but we know that its justification is the math that we just showed here. So this is the justification. Remember, justify means math, explain means I need some words. Okay, let's look at the next example. So this is, again, an old exam question. Given L, M, N, and P, and they just gave us some numbers here, radical 2, 3 radical 3, radical 16, and radical 9. Which expression results in a rational number? So the key here is that we're looking for something that is rational. So that means that it can be written as a fraction. Well, we can do this by checking in our calculator to see what we get when we do the sum of L plus M. So in this one, it's radical 2 plus 3 radical 3. So again, remember, based on your calculator, if you're going to do the math in your calculator, you have to make sure that you include the radical 2, and you either get out of the radical by hitting the over button, or if your calculator is the one that says square root and then has a parenthesis, that you close the parenthesis to say that only the 2 is under this radical. So it's radical 2, and then we're adding 3 radical 3. And then when we do that in our calculator, we get this long decimal, non-terminating, non-repeating, can't be written as a fraction. That's irrational, so that's not the answer. N plus P. So now we're going to try N, which is radical 16, and we're going to add P, which is radical 9. Well, if I look at these, even without going to my calculator, I know the square root of 16 is 4, and the square root of 9 is 3, so this is going to be 7, and that can be written as a fraction because I can put that over 1. Now, even if you didn't know that, you could have put it in your calculator to be sure, but it does give us a rational number here. I'm going to check the next one just to make sure I didn't read something incorrectly and say maybe I was supposed to find the irrational. So M plus N would be 3 radical 3 plus the square root of 16. And if I put that in my calculator, I'm going to get this long non-terminating, non-repeating decimal. So that's not the right answer either. It cannot be written as a fraction. And then the last one, if we wanted to do it, we could do the square root of 9 plus the square root of 2, or radical 9 plus radical 2, and we get this long, non-repeating, non-terminating decimal. Cannot be written as a fraction, so that's not the right one either. So what I'm looking at, when I see these, I can kind of see that if we're adding like 2 radicals, it's still going to be an irrational number. But if we add numbers that are perfect squares, it makes sense that they'll become rational. And even if we have one irrational and we add a rational number, it's still going to be irrational, which kind of makes sense. Okay, that's it for this video. We will continue tomorrow. Have a good night.